So, good day. I'm Janrel Diktahan, and today I'm going to discuss the topics all about multiplexing and demultiplexing. So, multiplexing and demultiplexing are techniques used to send and receive multiple signals over a shared medium such as a fiber optic cable or radio wave. Multiplexing and demultiplexing are processes that combine and separate data signals respectively. Multiplexing combines multiple signals into a single complex signal for transmission. And this is the process optimizes bandwidth uses and simplifies communication management. Then the demultiplexing. Demultiplexing separates the composite signal back into the original signal at the receiving end and uses a single input and directs it throughout multiple outputs. So this is what we call demultiplexing. Then the concept of multiplexing. Multiplexer, or what we called MUX or MPX, combined all inputs into a single signal, then process, then the middle, the communication channel, or what we call single communication channel. Maybe it can be wire or radio or wireless. So, demultiplexer or DMUX processes input signals by sorting it out into the original individual signals. So, the output is the original input signals. This is the concept of multiplexing. Then, special multiplexing. This is type of multiplexer. So, special multiplexing is the term used to describe the transmission of multiple wireless signals on a common frequency in such a way that they do not interfere with one another. Special multiplexing or SM is a wireless communications technique that increases data by retransmitting multiple data streams simultaneously from multiple antennas at the transmitter and receiver. So, SM is based on multi-input and multi-output, or what we call MIMO technology. Then, these are the techniques of multiplexing. First, wavelength division multiplexing, or what we call WDM. Wavelength division multiplexing uses different wavelengths to increase bandwidth by multiplexing optical carrier in signals onto a single optical fiber. Frequency division multiplexing, or what we call FDM, divides the total channel bandwidth into multiple subbands and assign each subband to a single signal or user. Time division multiplexing, or TDM, this is the usage is divides a communication channel into time slots and transmit each signals during its allocated time slot. So, code division multiplexing, or CDM. Code division multiplexing uses a unique chip code generated by pseudo-random sequence generator to encode the signal. Then the statistical time division multiplexing. Statistical time division multiplexing, it creates a data packet of only those devices that have something to transmit. And then the space division multiplexing. Space division multiplexing is a group of many individual channels or transmission paths together to save physical space. Then second to the last, the synchronous time division multiplexing. Synchronous time division multiplexing assigns a fixed time slot to each connected device, whether or not the device transmits data. And then the last, asynchronous time division multiplexing. Asynchronous time division multiplexing, it assigns time slot when connected devices have data that is ready to send. So the difference between these two is the synchronous, it is whether or not the device transmit data. So asynchronous is ready to transmit data. And these are the types and techniques of multiplexing. This it is the multiplexing techniques.
Good day, I'm Jonas Delphine. False, false code modulation, a digital techniques that converts analog signals into digital data. So false code modulation is can called also transmit another analog data types like video and music. So PCM multiplexer, a high performance multi-type long range Ethernet bridge is small size, low cost and very appropriate to the cost sensitive bridging application. So PCM multiplexer is a device that selects between a number of input signals. So PCM demultiplexer, at the receiving end of the communications links, the PCM signals is demultiplexed and converted back to the original data. So we have the circuit's formula. So current equals voltage over resistance. So PCM demultiplexer is a circuit that takes a single input and directs it to multiple outputs. The multiplexer converts serial data to parallel data. So we have a diagram PCM system. So first is voice to ADC to shift register. So we have a clock to shift register. So we have for the second is we have a counter, clock to counter, up to decoder. So decoder to digital multiplexer. So this part is shift register to digital multiplexer. So we have similar input channels. So we have a channels there to digital multiplexer. So after that we have out into including. So we have a baseband PCM signals. So agi sa diri sa encoding dayon lapos diri sa 2 twice pair or crucial si cable. So digital signals we have napini out diri is AM or FM modulator, and we have a carrier oscillator. Oscillator is RF power amplifier. So moagi ni siya sa Magi sa PCM AM or PCM FM. So lapos siya po niya sa two twisted pair or crucial cable. Next is we have a three benefits of PCM. So first is reliable, second expensive, third is highly resistant to noise. Next is duplexing. Duplexing is the method by which two-way communications are handled. So there are multiple matches for duplexing, including a printing process, a paper bonding process, and telecommunication terms. So we have first is printing. So duplexing, also known as a double-sided printing, is the process of printing on both sides of a sheet of paper. So there are two ways to duplex. So first is manual duplexing. So the user manually flips the paper to the print on both sides. So the automatically the the second is automatic duplexing. So the printer automatically prints on both sides of the page. So most printers have this feature built in. So next is paper bonding. So duplexing is the process bonding two or more sheets of paper together to create a single sheet of premium paper with two outward faces. A special glue is used to bond the sheets together, and the paper is then dried for several hours. And the last is telecom. So we have telecommunication. So duplexing is telecommunication tele, telecommunication duplexing is a telecommunication terms that refers to the gap between a downlink burst and the subsequent uplink burst, or vice versa. So next is, oh, and that's all for